We present a probabilistic motion model for skid steer wheeled mobile robot navigation on off-road terrains. Off-road navigation requires robots that can traverse a variety of environments. Skid steer wheel mobile robots are increasingly being used for this purpose due to their mechanical structure. However, accurately predicting their motion is a challenging task since they are prone to significant tire skid and slip at high operational speeds. Existing kinematic motion modeling approaches are unable to accurately capture the nonlinear effects of tire-terrain interactions. In contrast, we use Gaussian process regression and sigma point transforms to estimate the effects of tire skid and slip on robot positions and velocity estimates in a probabilistic fashion. Using an ensemble of GPs, we are able to use the same motion model for multiple terrains. For benchmarking purposes, we use an exhaustive real-world dataset for 3 different terrains: asphalt, grass, and tile. For more details on the dataset, please refer to the reference at the bottom of this slide. In general, we see reduced errors in linear and angular motion prediction. Further, as seen from the heat map, our model is able to accurately capture the skid and slip, which becomes dominant at high operational speeds. Using a motion capture system, we further validate our algorithm on 2 different lab terrains, tiles and synthetic grass. The ellipses represent the 3 sigma uncertainty in predicted robot positions. We see minimal errors in predicted robot positions and velocities. In future work, we will use the motion model output for uncertainty-aware stochastic model predictive control motion planning methods. Thank you for your attention.